Good day everyone. I'm Pablo Linares with HTI Global, and today's video is going to be related to human errors. On this particular video, we're going to start focusing mainly on swashplate errors caused by us, by the mechanics or engineer, depending on what country is watching this video. And I hope you like it. Let's start right away. In this particular slide, I'm going to explain something that's going to affect the 205, 212, and 412, and this related to the trunnions. We're going to have in all these models, you see there, we're going to have trunnions. This trunnion is where you're going to be connecting flight controls into rotating components. In this particular case, the swashplate. The swashplate right here, you're going to start connecting the extension tube that comes from the servos. And from here, you're gonna make the movement for the swashplate. What happened is this trunnion you see here, this is a 204 part number, and it costs a lot of money. Last time I checked, this was about $1,200. Now, if you look at in this one here, you see here, this one is called, or part number is KSP 9001-5. This is used in the military, and it's also called greaseless. It has no grease point, it's got no service. But here's the thing, this one here is not allowed to be installed in any civilian helicopter. Okay, and here's the thing, for what cost one, you can buy a lot of this. This is a cheap one, but this is only for military helicopter, and you are not allowed to install it on all this model, 205, 212, and 412. Are they going to fit on the same place? Yes. You can install this one here, it will fit perfectly, but this is illegal. So remember, anytime you are going to install a trunnion, make sure you have the right part number. This can involve you in some legal issues, even if the helicopter crash. I hope never happen, but if you have one of these installed in any other civilian helicopter, you are flying illegal. So remember, not because the part is cheap, it's good. Sometimes the part, you need to make sure you can trace it back to the manufacturer or to whom you bought it from. So be careful when you're going to start installing parts that look alike or similar in a different price, of course, but they are not allowed. If you look on the IPB books, you're never going to find this part number on neither of those models, 205, 212, and 412. So be careful when you start ordering parts, or you got a part to be installed in a helicopter. This slide is going to be mainly focused on the 205 and 212, where we have that kind of similar swashplate. And the swashplate, one of the sub-assemblies we got there is called the Scissor. This Scissor here, if you look at on the overhaul books, you're going to have some criteria. And for any of you, you never done any overhaul, or you never look into this manual, or you are new working on this kind of helicopters, every part, when you go on the overhaul manual, they're going to be, I want to say, a slice or section, depending on how much criteria or limitation you have in the different part of the component or the subassembly. This is the one we call a Scissor, and this is the drive links. Down here, we're going to see different zone. Depending on the zone, we're going to have different limitation. This limitation means that if you go over the amount showed in here, that part is scrap. Sometimes the part can be repairable, and down there you might have some notes that are going to tell you how much the part can be damaged before, and then after you repair it, what is the maximum allowed of repair depth. On this particular case, my point is for field maintenance, when people grease the Scissor. The Scissor, if you look at it here, the grease feeding is steel, it's very sharp. And this is pretty abused part when they degreasing it. That also can happen when people trying to replace the zerk or the grease feeding. All this damage you see here, if you, of course, it might be kind of exaggerated because you really went through the paint. But having a good look at the close section in here, you're going to see that the part really is damaged. Now, if you got this section where it's going to be around here, if we transfer it, it's going to be this zone. And I tell you that mechanical damage maximum allowed is going to be 10,000. Okay. Now, and after you repair it, you have 20,000. So that's how much damage you can have here. But this is something that us as engineers or mechanic can prevent. I know some of us have to do this in a rush, but remember, causing this kind of issue, you are really scrapping a very expensive and very critical part on the swash plate. This is a fly component, very critical part. So my advice, guys, anytime you're going to be doing greasing, make sure you point it out right in the center. And this kind of show that they might have some issue in the past with the zerk that is clogged, and they're putting a lot of pressure to put grease inside of the bearings. So be careful, guys, when you're doing this kind of jobs. Make sure you don't do this kind of damage, okay? On this one, we're going to be specifically talking about belt 412. And this happened many times. One of the practice as engineers or mechanic we have that every time you remove something, sometimes the hardware, we just put it back on it so we don't lose it and we know it's there, so we use it for reinstallation. In this particular case, you have to be very cautious. Many times when you work in a helicopter, you have different set of different groups working on the helicopter. Maybe one group's working on tail rotor, another group working on the engine, and so on. So you might be working on the swash plate, and the guy on the tail rotor might need to turn the tail rotor in order to do some kind of work on the back. So of course each one is calling out each other, so make sure nobody pinch or damage their fingers or cut off a finger. But as another thing happened, that when you start removing hardware and you put it back on it, you have to remember that whatever you install in the hardware, in this case the nut, you don't know what's going to happen unless you have already this experience, or somebody told you in training, or another friend of you tell you don't do this. And this is what happened. Every time you're going to remove the drive links, you're going to have some kind of hardware here. Let me just go back here. Okay. And we're going to have this cotter pin, the nut, and we're going to have this little it's a laminate, steel laminate to hold it for safety. I'm going to explain that in a moment. But look at down here. Look at the clearance between the stud and the inner ring ear. It's very close. So what happened is, in this specific case, the mechanic removed the nut, of course the cotter pin, the nut, remove everything, and in order to make sure he have it back in there, he got the nut, the nut, and he just put it back, a few thread on it. And what happened if somebody's turning in the back the tail rotor or main drive shaft or anything? This is what happened. Because the clearance is so close, and you remove the nut and you put it back on, and normally you don't go all the way, you start a little bit, this could happen to you guys. This is very bad. Now, let me tell you, if you really want to install the nut back on it so you don't lose it, you don't go back there, my advice is screw it all the way in so you can expose again through the nut the stud. If you look at it here, you want to do the same thing. You're going to install the nut back in all the way so you can see the stud coming out. So now you got enough clearance that you are not going to damage the inner ring horn. Again, if you see anything here, where you go for criteria for damages, you go to the overhaul books. Again, like we explained earlier, all this part, critical part, they're going to have in the overhaul book criteria for different zones of the part. In this particular case, you're going to have a blank section, a diagonal section, a segmented diagonal section, and a cross section. Each one have different dimension for criteria. This number in this one here, 10,000, this is the one we're talking about. That's the maximum allowed. Now, I cannot measure this picture by the damage by the picture, but really, for me, it looks like it's way over 10,000. Okay, that means that this Swashplate inner ring is scrap, only because the mechanics did not screw the nut all the way. Also, if you want to prevent this, do not install the nut. It's either way, or you install it all the way, or do not install it at all. Okay. We continue with the 412 Swashplate, and this time we're going to start talking about this special washer. This washer is come from another model. Is a 540 head, and this washer, we have some issues. I have a slide specifically for this. We're going to talk about this in a moment. But what happened many times, people, as before, they remove the drive link and they go back again and install the washer and the nut. And most of the cases, what could happen, you're going to scratch the inner ring. If you look at it here, this kind of damages, again, you go to the books and it's going to give you a different criteria than the one we talked earlier. We talked about this one earlier, now we talk with this one. And what happened is you go here on this section and I tell you that you have 20,000 damage maximum. Okay, so all this can be prevented when you're working on the Swashplate. Remember, the Swashplate rotate and tilt. So a lot of stuff's going on, and you have to be more cautious when there are different group of people working in the helicopter. Remember, if you're working in the back of the helicopter, the tail rotor, if you need to turn the tail rotor, make sure you yell to somebody else, turn it. Make sure nobody have the hand someplace that can lose a finger or damage the component. This is the washer I was telling you. If you look at it here, it's kind of hard to say, but the part number is 540. This part here, inside have a recess. You see that recess? That recess has to be in contact with the stake bearing right here. So we have plenty of space when the Swashplate tilt around. I was doing a class in South America, and we went to the helicopter. And really, I was very concerned when I saw this backward. The Swashplate, you're going to encounter this kind of issue. Now, if you look at the wording aft, that wording aft has nothing to do with the 412. That is for the 540 head. So in this particular case, the mechanics installed this part backward. Because even though it say aft, they put aft back, they flip it around. Guess what? Now this recess was on the front. Now this part here, it was closer. It was so close that make a beautiful marking on the drive link. This washer is made of steel and the drive link is made of aluminum. So can you imagine which one is going to get damaged? Of course, it was the drive link. This is a very simple mistake, and that kind of simple mistake can cause that this drive link break in flight. If that drive link break and fly, that is going to be a fatal accident. As simple as installing this washer backward. Again, this washer, the wording aft, is going to be showing outboard, not inboard, outboard. This is correct. It's going to be installed this way. Another thing, inside here, we're going to have another washer or spacer. The reason for this one is to make sure that the drive link is pushed away. We have enough clearance because the Swashplate tilts around. And when you tilt in the Swashplate and you go climb up there, you're going to see that these clearances are reduced or expand depending on the position. And that's what we want to make sure that at any position we have the Swashplate. Always we're going to have a clearance in here and a clearance in here. So this is very important, and again, be careful on this particular part of the Swashplate. Now this one, sorry that everything is 412, but I have this from a 412. But this issue, it can happen everywhere. Matter of fact, I'm seeing this on belt cranks. I'm seeing this in rod ends. I'm seeing this, like this one is one of the one that I help few companies already. The drive link on the 412. We're going back again on the drive link. Now, on this one, this is a very good sample. One thing I want to talk a little longer regarding inspections. Every time I go and do training in any countries, one of the questions I ask everybody during the inspection section is, when you have, let's put an example, 300-hour inspection, what is the first thing you do before you bring inside the hangar for doing inspection? And everybody says, we wash the helicopter. And then I say, that's wrong. And everybody looking at me like, what the hell I'm talking about? Here's what happened. By human being, nature, normally all the mechanical, the engineers, we're doing more tasks. Maybe we start getting all the paper ready for the inspection, and we got a helper to tell him, hey, go and wash the helicopter. A helper, maybe you having trained him, which also is a very good advice, and he doesn't know about any black stuff. This is called fritting, and because he doesn't know, he thinks it's dirty, he gonna clean it. So right now it's a tell me, even from down, not even climbing the Swashplate, we have an issue. But what happens if the helper wash it out? You don't know what's the problem. So it's a very good advice that before you bring the helicopter in and before you wash it, do a visual inspection. And this you can cut it when the helicopter's dirty. I can tell you guys, if you go on the hell hole and you start looking around before you wash it, you're gonna find a lot of black stuff, rivets. You're gonna have about 3 high locks on the bottom side of the servos. They are very known to get loose. And I do remember, I think it's 300 hours, 600 hours, we used to automatically replace them because it used to come loose. We used to try to install it with Loctite and all that. It's still coming loose. I don't know right now how you guys doing it, but those high locks are very known to start working. And when they're working, cause fritting. Now, for the new mechanics out there, fritting is one of the indication that tell you something is loose. This black stuff you see around here is called fritting. And that kind of coloring you see there, black stuff, is going to be produced where any two metals chafing each other, even a placard, even those lines, hydraulic line, they have tag tell you the flow direction. When this little tag is touching an aluminum tubing and they're touching each other, it will cause that black stuff. So every single time you see any seam like this, you just have to stop and investigate further. This is wrong. Now, after talking a little bit about this, one of the problems with this is the bearing by itself, okay, is 2 parts. You're going to have the ferric and the staking part, okay? This part here is the staking. This part here is the staking, and this is the bearing. When you look on the books, Bell Helicopter books are going to tell you that this bearing, the ball bearing here, inside the staking, you are allowed to have a maximum of 15,000 axial play. Axial play, this way. This way. Now, this particular case came to my attention. You can see there were a big conflict between mechanics or engineer. This guy was South America, was engineer and inspectors, where the inspector was telling the mechanic that that was okay to fly like this. And the mechanic, I trained him many years back, and he say, Pablo, he showed me the picture, hey Pablo, we have this issue, and the inspector said that's good to fly. When I saw this, just like this, I said, no, this helicopter is grounded. When they'll tell you the 15,000 play is between this and this, not between the staking and the drive link. Okay, so you have to remember, when you start seeing this black stuff coming out, normally it's because the bearing, the staking section, this part, has play against the drive link. Again, the bearing is made of steel and the drive link made of aluminum. What happened right there? You are elongating the whole of the drive link. Maybe looking at this after we take it apart, maybe this drive link is already gone. Now, my conclusion, my final point in all this, when you have a bearing, a stake bearing, having play, look at it. Normally, a staking bearing, when they have the normal play between the ball bearing and the staking section, they don't make that black stuff, okay? What you're going to start seeing is Teflon coming out. The worst case scenario, when the whole thing is gone, maybe you start seeing freeing and black stuff. But this is going to happen right away. And again, guys, if you have this kind of case, I don't care about 0.5, 10,000 play. No play allowed. No play allowed. You are not allowed to have any play between the staking and the drive links. And this specific case is going to be the same for the rotoring on the PC links, on the tail rotor PC link, or everywhere you have a stake bearings. When Bell give you an actual play, Bell is talking about between the ball bearing section and the staking section. Okay, not between the staking and the part. That is not allowed. Better picture. This is the staking, and this is the ball bearing. Well, we continue on the 412. Here, we're going to have, again, the Swashplate. And then what happened, what I'm seeing a lot, I've seen this since, I think, 2006. When I was in Bell, I went to a country in South America. I don't want to say the name. And I was talking with one of the hiking rank military guys that he was in the decision group or team to change the model of the military. So in this particular case, the high-ranking officer came to me and said, well, we like the 412 because the 412 is very similar to the 212. And I was looking at him and saying, no, sir, they are very different. They might look the same on the fuselage, but that's it. Everything else changed. And the same thing that the practice the mechanic does on the 212, you cannot bring this and take it to the 412. And this is one of the examples. Another issue. When I went to that country to do training, every single refacing lever was wrong or damaged. Refacing levers are this part here. You see this, right? This is called refacing lever. They are made of aluminum. Now, many years back, originally, Bell have the rotor in here made of elastomerics. It didn't work very well. And then they came up with the bulletin and they installed steel rotor bearings, ball bearings. And they have to install this bracket here to keep the rotor center. But this is made of steel. And back here is very sharp and very damaging. So what happened is, the mechanics, when they have to work on the head, sometimes you need to disconnect the PC link. This is called the PC links. And what happened is, when you disconnect the PC link from the top, many mechanics just let it rest. And what happened is, when you have this PC link rest, this part here move down and touch the bottom side of the refacing lever. Okay, and these damages on that particular helicopter were out of limit. No one, not two, but all 4 refacing levers were gone, out of limit. Again, I already told you, you go to the overall book and you find the criteria for that zoning specifically, which is not much because there's a lot of stress on this part of the refacing lever. And be careful, you're not supposed to doing this. That let the piece of link resting on the bracket against the refacing lever. This is a very bad practice, okay guys? Don't do that. If you have to do it, you want to do it, trying to make sure you put a wedge, a rubber wedge between the bracket, between the bracket and the refacing lever, okay? So only rubber touch between them. Okay, this is the last slide for today on human errors. And this one here again, as I tell you before, not because you're working in 212 all the time and you're going to switch and start doing the same thing you used to do on the 212 during the 412. No. On the 412, this is the mast. And this mast is very peculiar on the 412. You have a very large radius here. And this radius you don't have on the 212. No, 205, 212, you don't have it. Only in the 412. Now, when you're working on here, you have to be careful something else. For this example, just imagine you are already with the piece link disconnected. You're going to work on the Swashplate. You're going to remove the collecting lever. You're going to do inspection, or you're going to change the pin or the buffing or the bushings and so on. So you have to remember, not because you work on 212, this is going to work the same way on this one. This example, this slide I'm going to show you here, if you don't know what you're doing, you can be damaging $40,000. That's the cost of the post by itself, the mast with nothing on it. Okay. Now, in here, that radius, when you're working in this section here, okay, just imagine, as I already told you earlier, you disconnect the PC link. Now there's nothing here. It's heavy though, and you're gonna come down here and you're gonna remove those pins because you're gonna remove the collecting lever in order to replace this bushing we got in here. Now this happened already a few times and they sent me the picture. Sadly, my advice, it can be exaggerated because the mast on this location is painted. Maybe it's the pin the only part, but as soon as you remove these pins and the links are not connected, the collecting sleeve, this part that go from here all the way down, is going to drop. And not only dropping will be the problem, but again, if you have different group of people working the helicopter, another guy is turning the main right shaft or the tail rotor or whatever, now because all this weight here, what happened? Look at these beautiful markings. Okay, I don't know for sure if this one was scrap or not, but it's already been scrapped few of those, because what happened is the sleeve, as soon as you remove these pins and you don't have the PC link connected, it drops. Many years back, where we used to have these things 6x2, we used to put 2 pieces of wood across the top of the sleeve here so you keep it higher. Nowadays, what happened, they have these 2 half moon going inside so the Swashplate will not turn around, don't oscillate. But in the past, we used to put it here. Now, this doesn't happen on the 212. It happens on the 412. So every single time you got the PC link disconnected and you're going to be working the links here, make sure you protect the sleeve to don't drop down. Be careful. One mechanic, because he was very good, he didn't want this to happen. He put a rack on it. He put a rack between this and the sleeve for no damages. But he forgot to remove it when they're going to do runouts. What happened is the rack caught in here and it caused friction and starts smoking. When it starts smoking, thank God never caught on fire, but they found some indication of overtemp in this area. That means the $40,000 post was scrapped too. Again, you have to remember that in this helicopter, like any other helicopter, whatever you're doing can cause an effect someplace else. And things like this, you read the book, is nothing written down about this. That's why my advice to you guys, training is a key to lower your cost, making you guys more efficient, and being safe working at your helicopter. Not only for you guys, but also for the equipment. You will be first priority, the human beings, and secondly, the helicopter. Okay? I hope you like the video, and the more issues you guys send me, you can send it through email, WhatsApp. I can create more videos so everybody, including myself, will learn about our own mistakes so nobody else replicate it. Okay? I hope this set of a video I'm going to start creating will help every single one out there. Thank you very much for your time and have a great day. This is Pablo Linares with STI Global. Thank you.